So this time is solving by substitution, and the question that always comes up is how do I know when to use which method? And it's a personal choice, but you need to be able to do all of them, so figure out when this one is going to be good. Why do I call it double substitution? And where should you go back for that second substitution of the double substitution? And the ever popular, do I really have to check my answers? System of equations like 4x plus 3y equals -2 and x equals -5y minus 9. So one thing I would recommend is keeping your original equations safe. I'm in the habit of drawing a box around them so I don't mess with them, because if you aren't sure what you started with, it's real easy to get the wrong answer. I also write that empty set of parentheses there to remind me that I'm looking for an ordered pair. I need to not stop when I get one answer. I've got to find an x and a y. We call this by solving by substitution, because what I'm going to do is I'm going to substitute a chunk of stuff in for one of the variables. We have two variables in two equations. We want to turn that into one equation with one variable, because then we can solve it. So this one's a great candidate to use substitution on because we have x alone here, right? Since x is alone, this is a great way to use substitution on. So I'm going to write 4, and then instead of x, I'm just going to put some parentheses here, plus 3y equals -2. And that's because I have a value for y. Now the value for y is not what you normally might think of as a value, but this whole thing is what x is equal to. So I'm going to put that whole thing down there. Now I said I was going to keep that box clean, but since this is the first one, I want you to know where I got this chunk of stuff from. I got it from right there. So if that's what y is equal to, that's what I'm going to substitute. I'm sorry, that's what x is equal to. That's what I'm going to substitute in place of x in my other equation. So now I have one equation, and it only has y's in it, so I can solve it. So to solve it, I'm going to distribute. So we got -20y minus 36 plus 3y equals -2. And then I'm going to combine my like terms. I've got -20 plus 3 is -17y minus 36 equals -2. I'm going to add my 36 to both sides. So I've got -17y equals 34. And if I divide both sides by -17, I won't show all the steps on all of them, but on this first one I will, I end up with -2. So the reason I put that parentheses up there at the top is to remind me I'm not done. So, right, we already substituted once. This was our first substitution. That resulted in one of our answers being y is -2. Now we're going to do our second substitution. Right? Now that we have that value, our second substitution is going to be taking that -2 and plugging it in. Now the question comes, where do I plug it in? Now I always go back to either of my original equations. You can pick either one, but because this one already was solved for x, that's going to be the least work. So x equals -5 y minus 9. I just wrote the whole thing again, but now I have a value for y. -5 times -2 is +10. So x equals 1. Now do I have to check? Well, again, you don't have to do anything in life, but it's a great idea because there's just so much that could go wrong. So we're going to check with the other equation. And so I'm going to go to 4x plus 3y equals, whoops, -2. I'm going to substitute my x and my y values, right? So that came from that ordered pair that I'm pretty sure is my answer. Then I've got 4 minus 6 equals -2. And when we say we check, the reason I'm such a stickler on it here is knowing that that's a true statement, -2 equals -2, that's what we're looking for. That means that's a solution to that equation, to the system of equations. There are an infinite number of solutions to each of the equations, but that's the only one solution that fits for both of them. So that ordered pair, again, if we were to graph these, that's where the lines would intersect. Okay, so I said the last one was kind of set up perfectly to solve by substitution, and this one's not quite as perfect. I have -2x plus y equals 3, and I have 7x minus 4y equals -16. Keep a nice clean copy because we're going to start messing with those, and put your answer blank here because, again, it's just nice to, if you're checking your homework, not to have to search for it. And again, I've seen way too many people get one answer and then stop. So this one I said isn't in as good a shape as the last one because we do have to do one bit of thing before we start substituting. We've got to solve for y or x, but in this case it's a good candidate for substitution because it's really easy to get one of the variables alone here. So we're going to solve this for y. To solve for y, we're just going to add 2x to both sides, and we get y is equal to 2x plus 3. Again, that's really just putting a standard form equation into slope-intercept form. So now this equation is just this equation wearing a costume. They're one and the same. And now we have this chunk of stuff that y is equal to. So we can write the other equation, but where there used to be a y, we're going to put this chunk of stuff, right? All that stuff goes where the y was. So we have not -4y, we have -4 times 2x plus 3, because that's what y is equal to. So now, just like before, it's going to be the same steps. Usually these are going to be the steps. We're just going to distribute. We got -4 times 2x is -8x. -4 times 12, or -4 times 3 is -12. Getting ahead of myself. And then combine like terms. So we have -x minus 12 equals -16. Add 12 to both sides. We've got -x equals -4, which means I divide both sides by -1 or multiply both sides by -1, whichever way you prefer to think about it. And that means we've got our value for x. Looks like x is 4. So we did our first substitution, right? So this time we had to do that one bit of work to solve for the variable first. But that's our first substitution. Now that we have one variable, we're just going to go back and substitute that into one of our equations. Now, I could go back to that y equals equation, but what if I got it into y equals form incorrectly? So I highly recommend you go back to one of the original equations. I'm going to go back to this equation, and then I'm going to substitute that 4 checking my signs carefully because I know that's one of my things I can do very easily is copy the incorrect signs. When we get into 3 by 3s, 3 equations, 3 variables, you're going to see I get a little crazy trying to prevent errors. So it looks like we've got 4, 11 is where those two would intersect. Again, we could graph both of those equations, and then that would be the one point where those two lines intersect. That doesn't mean they're perpendicular, it just means they're not parallel. and they intersect somewhere. So again, we're always going to do a check. Let me make a little note here. This was our second substitution. All right, so now we're going to do a check. So last equation I used was the negative 2x equation, so to my check I'm going to use the other one. It's not that I have to, it's just the more you kind of make sure you check every, bounce back and forth, you're kind of making sure you haven't read something wrong and you're continuing to read it wrong. Okay, so I plugged in my 4 and my 11. I got 28 minus 44 equals negative 16. 44 minus 28, 16. 44 was negative, so yep, that works. So I know that my answer is correct. Again, my answer is not negative 16. My answer, that's the other reason I like writing that answer up at the top. So this one is kind of your typical problem that you're going to do on your homework. I'll put the fancier examples, no solution, infinitely many, and a word problem on a second video. Okay, so those were good choices to use substitution because one of the variables didn't have a coefficient, right? Notice I did two substitutions both times. Don't go back to an equation that you've worked with. Go back to one of the original equations and please check